Async Rust is a bad language. But to get at whatever the hell I mean by that, we need to talk about why async Rust exists in the first place. Let's talk about it. Okay, this is great. I love this. I already love this. Starting off the conversation, giving us the proper context. Let's go. Modern concurrency. They're green, they're mean, and they ate my machine. I don't get it. And that guy's face doesn't look like he wants to be here either. Ooh. Suppose we want our code to go fast. We have two big problems to solve. We want to use the whole computer. Code runs on CPUs, and in 2023, even my phone has 8 of the damn things. I got a new phone, by the way. Look at this sweet Pixel 7. It's pretty neat. I no longer have a bright line down the middle of my phone. Pretty cool, huh? If I want to use more than 12% of my machine, I need several cores. This is true. Even in some of my best attempts, I still can't get Node to use 100% of the CPU. I've tried so hard to make it just use as CPU, and I cannot make it. We want to keep working while we wait for slow things to complete instead of just twiddling our thumbs. Sending a message over the internet or even opening a file takes an eternities in computer time. We could literally do millions of other things meanwhile. Very fair. And so on. We turn our friends parallelism and concurrency. It's the favorite hobby of CS nerds to quibble over distinctions between the two. So to oversimplify, parallelism is about running code in parallel on several CPUs. Concurrency is about breaking a problem into separate independent parts. I'll give my take on it, which is parallelism is having machine instructions executed simultaneously. Concurrency is having tasks that do not need CPU to move out of the way and allow other tasks to run while it's waiting for a result. Concurrent my nuts out your mouth. Okay, I don't know how I got that one, but that's about fair. Is that about a fair-ish statement? Wrong again. Parallelism is more than one thing happening at once, whereas concurrency is stacking them like bricks. Parallelism is a subset of concurrency. I don't believe that. Parallel is at the exact same time, current at the same time interval. Okay, that somehow makes it less clear. Now I think everybody's more confused at this point. I'm still confused. What's the difference? Okay, think of Node.js. When you do think of this right here. Here we go. This code. Okay, not that code. Vim test this right here, right? 1 is going to take 1 second. 2 is going to take 2 seconds. We can either run them one at a time. This is not concurrent or parallel, or run them both at the same time. But here's the deal. 1 will run until it relieves any need of the CPU. Then 2 will run and relieve any need of the CPU. And then 1 will pick back up after its 1 second wait and then start running and then be done. And then 2 will pick up after 2 seconds and pick it up. This will take a grand total of 2 seconds. It's concurrent, but it's not parallel. 1 is not executing at the same time 2 is. That's concurrency. Concurrent processes overlap. Parallel runs literally the same time. That's why I was specific. There's at least 2 lines of running machine code. Like something is happening. 2 different, because you can have parallelism and they're not running the same code. They don't have. I don't think there's any requirement that it has to be identical code being ran. They could be running different parts. Chipboard politics, yeah. Okay, whatever. I think we all get it. We're moving on. These are not the same thing. Single-core machines have been running code concurrently for a half century now, but they are related. So much online, actually ignore. Dude, we literally just did this. We're doing this, okay, right now. Ignores how often we break programs into concurrent pieces so that those pieces can run in parallel and interleave in ways keep our cores crunching. We didn't care about performance. Why would we bother? So let's see. How do I concurrency? One of the simplest ways to build a concurrent system is to split the code into multiple processes. After all, the operating system is lean, mean, concurrency machine, conspiring with your hardware to make each process think it has its whole box to itself. The OS scheduler gives us parallelism for free, running time slices of any process that's ready on an available CPU core. Once upon a time, this was the way, and we still employ it today whenever we pipe shell commands together. Let's talk about Gulp build tool. Oh no. A lot of you JavaScripters are discovering that it is a lot more efficient to pass data from task to task rather than writing it to disk between each step. Or ACA actors in Scala. Concurrency sure is simpler with non-shared memory and immutable messages, huh? Okay, let's begin with process and pipes. They've been in Unix for 40 goddamn years. This is actually really funny, by the way. This is really good. It's been happening forever. But this approach has limitations. Inter-process communication is not cheap, since most implementations copy data to OS memory and back. Yep. Mutex-based concurrency considered harmful, or Hoare was right. Some people, when confronted with a problem, think, I know, I'll use threads. And then they have two. This is such a good statement. This is a beautiful statement, right? This is a beautiful statement, okay? This is parallelism getting awful. We can avoid these overheads using threads, processes that share the same memory. Common wisdom teaches us to connect them with mysterious beasts like mutexes and conditional variables and semaphores. Isn't a semaphore just a mutex with a wider lane? It just has a higher count to begin with. Anyways, yeah, I know. I'm just saying that just so, okay. Anyways, this is a dangerous game. So, I mean, I like using this. I have my little test clients all use this. I think it's a lot of fun to use semaphores to produce asynchronous code. It's fun. I mean, I actually enjoy it. A little Tokyo spawn, a little semaphore, a little glass of wine, and you got yourself a segfault. This is a dangerous game. Simple mistakes will plague you with the race conditions and deadlocks and other terrible diseases that fill your code with bugs. But only on Tuesdays when it's raining and the temperature is in the middle of 3. It is a multiple of 3. Oh, gosh, it's right in the middle. And God help you if you want to learn how this stuff actually works on modern hardware. Fair. All those are fair statements. All of it fair statements. There's another way. In this 1978 paper, Communicating Sequential Processes, Tony Hoare suggests connecting threads with queues or channels, which they can use to send each other messages. This has many advantages. Are we just slowly becoming Go? Is this literally a statement of like, hey, man, you want to hear about Go? I think this is where we're going. Or Erlang. Okay, Erlang. Sorry, it's Erlang. Dude, Erlang's is literally the Simpsons of programming. Oh, is this Goat? Erlang did it. Okay, shut up. Threads enjoy process-like isolation from the rest. Sorry, the music was a little loud. Threads enjoy process-like isolation from the rest of the program since they don't share memory. Bonus points for memory-safe languages that make it hard to accidentally scramble another thread. Yeah, Rust. Each thread has very obvious set of inputs, the channels it receives from, and the outputs, the channel it sends to. This is easy to reason about and is easy to debug. It's actually true. It is very easy to debug these type of problems. Instrument the channels for powerful visibility into your system, measuring each thread's throughput. Channels are the synchronization. If a channel is empty, the receiver waits until it's not. If a channel is full, the sender waits. Yeah, this is actually, I mean, this is beautiful. Threads never sleep while they have work to do. Graceful pausing if they outpace the rest of the system. Okay, after decades of mutex madness, many modern languages heed Hoare's advice and provide channels in their standard library. In Rust, we call them sync channel. Okay, most software can stop here. Building concurrent systems with threads and channels. Combine them with tools to parallelize CPU-intensive loops, like Rust Rayon or Haskell's PAR. Ooh, Haskell mention. Can we get a W? Haskell mention. Pick. Come on down, pick. Dude, anytime Haskell gets mentioned, there's just high fives. Like 35 individual people just start high-fiving each other, and they're just like, yeah, they recognized us. Let's go. Pick sitting there at the leader's full-on cult enthusiast. Oh, it's so good. And you've got a powerful cocktail. I do think that I've relied too heavily on async await, and maybe I do need to consider more just playing with this kind of stuff. But ludicrous speed, go! Some problems demand a lot of concurrency. The canonical example described by Dan Cagle. Did I say his name right? The man's name is Cagle. Did he invent anything else? Is there any other well-known item that this Dan fella happened to know about? I'm doing one right now. Oh, that squeeze was great. As the C10K problem. Back in 1999, is a web server connected to tens of thousands of concurrent users. At this scale, threads won't cut it. While they are pretty cheap, fire up a thread per connection and your computer will grind to a halt. To solve this, some language provide a concurrency model where tasks are cheap and managed by in user space, i.e. without operating system's help. A runtime schedule these tasks onto a pool of OS threads, usually sized so each CPU core gets a thread to maximize parallelism. Very hard word, by the way, to say. Rust calls this the MN thread problem. Okay. This scheme goes by many names: green threads, lightweight processes, fibers, coroutines. Did you know that in React, they also use the term fibers starting in React 16? As somebody who's been recently going through their source code and reading a lot of lines of it, just saying, okay, that it exists in React as well. And more, complete and with pedantic nerds endlessly debating the subtle differences between them. Rust comes in with this problem with async await model, seen previously in places like C# and Node.js. Here, functions are marked async, don't block you, but immediately return a future or promise that can be awaited to produce the result. A little different, though, than Node.js. In Node.js world, an async function is greedy. It runs right away. It's hot is another term for it. Whereas with Rust, unless if you call .await, it doesn't ever actually run, which can bite some serious ass, okay? You may not realize that. I've heard the term cold be used, lazy. There's a lot of terms for it. Foo returns an int. Async foo returns a future that we can .await to get it. Pain.await. I've been here before. You should have thrown a little arc mutex somewhere in here. On one hand, futures in Rust are exceedingly small and fast thanks to their cooperative schedule, stackless design. But unlike other languages with user space concurrency, Rust tries to offer this abstraction while also promising the programmer total low-level control. There's a fundamental tension between the two. And the poor async Rust programmer is perpetually caught in the middle, torn between the language's design goals and the massively concurrent world they are trying to build. Rust attempts to statically verify the lifetime of every object and reference in your program. I still truly don't understand pin and unpin. Okay, I keep trying. Okay, I haven't tried in a little while. I'm just saying that sometimes you gotta pin it. Sometimes you want to not unpin it. Sometimes you want to unpin it, okay? Sometimes you want an async reader plus unpin. I know, then someone's like, pin doesn't move. You're like, oh, okay, that makes perfect sense. Okay, I get it now. I get it. Super cool. Design goals and massively concurrent world they're trying to build. Rust attempts to statically verify the lifetime of every object and reference in your program. At compile time, futures promise the opposite, that we can break code and the data it references into thousands of little pieces runnable at any time on any thread based on conditions we can only know once we've started. A future that reads data from a client should only run when that client socket has data to read, and no lifetime annotation will tell us when that might be. It's actually a really fair take. So that's why send. Yeah, I was about to say, this sounds like a send problem. Assuring the compiler that everything will be okay runs into the same challenges you see when working with raw threads. Just raw dog those threads. Data must either be marked as send or moved, or passed through references with a static lifetime. Both are easier said than done. Moving, at least without cloning, is often a non-starter. Dude, it's so annoying. This is like this part is such an emotional bruising moment. Do you know what I mean? Like, this is such an emotionally bruising moment when you start getting into this. Oh my goodness. Since it's common in async code to spawn many tasks that share a common state, the references are a pain too. There's no thread scope equivalent to help us bound future lifetimes to anything short of forever. I thought there was some level. I thought in Mara's book on thread atomics or Rust atomics, there was some sort of thread scoping that allowed some version of this. I could be wrong, though. I could be very, very wrong. Foo, big chungus. Get that big chungus out here. Async foo, big global static ref or something similar. Horror chungus. Sendable chungus clone. That's pretty good. You gotta have that sendable clonable chungus, okay? It's a requirement. Unlike launching raw threads where you might have to deal with these annoyances in a handful of functions, this happens constantly due to async's viral nature. Since any function that calls async function must itself be async, so I talked about this earlier. This is the problem of a leaky abstraction. When you have one thing that uses something, the thing that uses it must also become it itself. And so you just like all the way back. Or you create something that can walk a future in Rust, which I'm still not quite sure of how that works. You need to solve this problem everywhere, all the time. Just arc my shit up. Toss a little mutex on there. A seasoned Rust developer will respond by saying that Rust gives us a simple tool for dynamic lifetime spanning multiple threads. We call them atomic reference counts, or ARC for short. Ha 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 ha! Did I do a good Rust meme? While it's true, dude, so Republican versus Democrat functions, yes, this is what we're talking about. While it's true that they solve the immediate problem, borrow, check, and R code compiles, they are far from the silver bullet. Used pervasively, Arc gives you the world's worst garbage collector. Like the GC, the lifetime of an object and the resources they represent, memory, file sockets, is unknowable. But you can take this loss without the wins you'd get from actual GC. It's true. You get all of the inconveniences of Rust with none of the benefits of GC. It's pretty good. Don't buy the GC as slow FUD. Yeah, I think that like Discord probably did the largest disservice ever to the GC as slow and bad. They're like on an old version of Go. They had no tuning that was being done. There's a lot of improvements in Go and what they've been doing with that, and I really hope Memory Arenas come out. But it's true. Don't buy the GC as slow FUD. GCs can be fast. You can make things good in a compiled language with the GC. It is possible. Go GC is great. It's a great GC. The claim is misunderstanding of a latency versus throughput at the best and bizarre psyop at worst. Throughput at best and a bizarre psyop at worst. I love a good psyop. I am all in on a good psyop. A modern moving garbage collector gets you more allocation throughput, less fragmentation, and means you don't have to play Mickey Mouse games when weak pointers to avoid cycle leaks. Yep, and you can even trick the system programmers into leveraging GC in one of the world's most important software projects by calling it deferred destruction. Kernel.org, someone snuck in a GC? Someone snuck in a little deferred destruction. Step B, the above key to underlying RCO's deferred destruction. HR here. Hold up, please. That's actually pretty funny. Another random nonsense. Let's see, other random nonsense. I'm not sure if that's actually real or what they're saying, if it's really a garbage collector or anything, but it's just a funny idea that exists. Because Rust coroutines are stackless, the compiler turns each one of them into a state machine that advances to the next await. Yeah, if you've ever looked at some of the code that is generated, it's pretty wild. But this makes any recursive async function a recursively defined type. A user just trying to call a function from itself is met with inscrutable errors until they manually box it or use a crate that does the same. Oh, I've never tried a async recursive function. Huh. There's an important distinction between a future, which does nothing until awaited, and a task, which spawns work in the runtime's thread pool, returning a future that marks its completion. Exactly, this is true. I mentioned this earlier. There's nothing keeping you from calling blocking code inside a future, and there's nothing keeping that call from blocking the runtime's thread. It's on. Also true. You know, the entire thing we're trying to avoid with async. I mean, I've done this a lot of times with Rust. I did this a lot of times with Rust. It can be quite tricky. Running away. Always, Monty Python's always a solid reference. What is your favorite color? Mixed together, this gives you async Rust, a much different flavor than a normal Rust. One with many gotchas that are harder to understand and teach and pushes users either to develop a deep understanding of how abstractions actually work, writing complicated code to handle them, or sprinkling arc, pin, static, unpin, pin project, some structures with also a pin macro somehow sprinkled on them. You know, and other sacred runes throughout their code base and hope for the best. This is me. I'm pretty much on this team. I'm on team Arc Mutex. You know, I'll take option 2. The thing is that you got to remember that when they say this, what they mean is that it's not something like, you know, like, don't worry about that. You know, like the difference between going from, geez, like, I don't understand the DOM because I don't get trees, is like, it's a small gap, right? Like, we can all agree that that gap looks something like this, right? It's a small little gap, right? You have to learn a little bit, and then you kind of get it. And you're like, oh, okay, I understand how you recursively descend. I understand breadth first versus depth first search. Okay, I get this. Whereas, I added an A at the end of it. Whereas, when it comes to Rust async, it's like the amount of stuff you do have to learn. You have to actually learn what pin is actually doing. You have to, you have to learn about like what is actually happening with the Rust runtime and how async is handled. What the hell's happening? What are all these extra things that are going on? Why do you have to mark some of these structures as some sort of pin project? Like, it just keeps on going, right? It just keeps on happening and keeps getting thicker and thicker and thicker. It takes a while to get over it. You know what I mean? It just does. All right. Rust proponents. I'd consider myself one. Might call these criticisms overblown, but I've seen whole teams of experienced developers trying to use Rust for some new project mired in this minutia. To whatever challenges teaching Rust has, async adds a whole new set. Agreed. Cries in async is a real meme because it really exists, right? It really, really exists. Rust is like a learning pointers and mallocs all over again. Yeah, but it's like, honestly, just Rust. It's pretty simple. Right? Like, I genuinely, just Rust, a little CLI that does something, it's pretty straightforward. But the moment you get into these, like, some of the more arcane sides of Rust, the difficulty is just like a serious step function harder, right? You're learning both a concept and how to express it in Rust's kind of constricted language and how they do things. Sync Rust a day, async Rust, that. To a degree to which these problems aren't just a thing in other languages can't be overstated. In Haskell or Go, async code is normal code. You might say this isn't a fair comparison. After all, those languages hide differences between blocking and non-blocking code behind a fat runtime, and lifetimes are hand-waved with garbage collection, but that's exactly the point. These are pure wins they are doing with this sort of programming. It's true. It's very true. Maybe Rust isn't a good tool for massively concurrent user space software. We can save it for the 99% of our projects that don't have to be. I love Rust when doing CLI tools. I love Rust for CLI tools. So yeah, I agree with this. I genuinely agree with that statement. One, a file which could be on the other side of the internet. Thanks, NFS. I'm not sure what that is. Two, we could cut down IPC overhead by sharing memory between processes, but this gives away one of the main advantages of multiple processes, the OS isolated from each other. Yep, I like that. Mara Boss recently put out a fantastic book that, despite targeting Rust specifically, does a wonderful job explaining the fundamentals of low-level concurrency in any language. I've read through most of the book. It's It's a pretty good book. If you don't have time for the whole book, I've done my best to sum it up in a few pages. Also super cool. Of course, I'm simplifying here. Not every programmer can express. Not every program can be expressed as a DAG. Fair. You'll find good occasions for other primitives, say atomic flags to indicate changes in global state. Still, Horse model is great default, and I've always found it helpful to think about how data flows through my system. Each thread has 4 kilobyte control block in Linux, and switching between threads require a trip to the operating system scheduler. This context switch to the OS memory is much more expensive than a normal function call. Fair. Uniquely, Rust doesn't provide a runtime for its features in the language, delegating instead to libraries like Tokyo. This is great for users. Rust build tool Cargo and ecosystem gives developers freedom to choose alternatives that are better suit unique environments they find themselves in. That's true. That's true. It sucks that people like Tokyo also have to shoulder the community for most concurrency. Tokyo! Right? Like, I do think that is the sucky downside of this, is that people who develop these alternatives are truly, like, that's a pretty tough job to have. But it's a detail that largely immaterial to our discussion. One that can imagine a world where Tokyo is built into another language and all the same rules apply. You can break a chain by commanding the entire runtime to block on. This is true, and I've done it many times, on a completion of a future. You probably shouldn't do this pervasively since it isn't composable. If a function blocks on a future and that future calls a function that blocks on a future, congrats, runtime panics. Facts. 8. Learn more in without boats, future and segmented stacks. In the C++ paper. Okay, cool. Amos Wagner, a.k.a. Faster Than Lime's Pin and Suffering, is a fantastic snarky intro. There you go. Now you see it all. I actually agree with this. I think that my ventures into async Rust, though I've built several programs that I'm happy about and I've done well, and I'm very, very happy that I did. Some using a bunch of async await, some not. In fact, like, if you look at this little shooter game, oopsies, I just did the wrong thing there. What is happening? My brain just totally went to shit twice. I used a bunch of, I used semaphores to kind of do this and do some nice little fun things right here and join a couple little items right here. Enjoyed it very, very much doing this kind of stuff. I have actually enjoyed these kind of things, and I think it's really fun to use semaphores and all that, but ultimately at the end of the day, I'm still relying on the async nature of it, and I do a bunch of box leakings for that exact same reason. I just need a static reference, right? I just need a reference out that I can just have everybody else using. This article screams skill issue. So My big problem with this is that I don't believe that. You know what I mean? Because here's the problem with that statement in general. And one of the reasons why I semi-dislike the phrase skill issue is that some are just genuine skill issues. But some, the requirement to be good at async Rust, not just like kind of good, right? You could build a simple web server that cruds out stuff, that does stuff, not hard async. We can all do that super simple. Throw up a Terso client, hit the database really easily. By the way, Terso is doing something incredible that I'll be talking about here soon that involves millisecond transactions or microsecond transactions. It's incredible. But nonetheless, it's like that's simple. Simple async is simple in Rust. Large async programs become very hard in Rust and can become very hard in Rust. And so I really don't think that I don't think this article is far off. I think that's why, again, I just really, really love. And the thing is that when you have to do something, like if you're going to get a group of people to try to learn async Rust to the fullest extent, you're asking them to learn Rust to an exceptionally deep level. That's like, do you just want to be a Rust-only Andy? Or are you someone that's more like, I'm truly trying to be someone that works on many stacks of any kind? And so that's kind of the thing you have to choose to do. And I'm not saying it's bad. I like Rust, but I like Go, and I also like TypeScript, and I also don't mind working in just JavaScript with JSDoc, and I also don't mind working in Lua. And when I have to, I've done that one big, gigantic, multi-threaded Objective-C program that was pretty terrible because I hate Objective-C. I'll even work in C++. I'd love to get into OCaml, right? And so it's like, for me, it's like, I'm fine kind of being in a bunch of places. You know what I mean? I'm fine doing a bunch of stuff, but it also means I can't go super deep to the level of understanding Rust async at a compiler level, because that would just be really hard, but I could get there. I mean, theoretically, I could just take that amount of time and do it. I like TS, yeah. TS is just fine. TS, here's the deal. TypeScript takes a shitty language and makes it slightly less shitty. Anyways, I don't mind TypeScript. I just think it's still a shitty language. It still has shitty things. And I think large TypeScript programs are bound to be incredibly emotional, right? That no matter how much you want it to be good, it is an act of refactoring types and logic that is very annoying. So that's that. Small programs, I really am fine using TypeScript. You know, if I just need to get something really quick, I'll just use that sometimes, that or Rust. I tend to use Rust or TypeScript for a quick CLI app, depending on how I'm running it. Now that I have Bun, I'll probably use TypeScript more frequently for something easy. So, just thoughts. But I like this. I like this take. I actually really like this take. Great job, bit bashing. Sweet article. That was a sweet article. Typically, whenever I do anything with the CLI, I actually pick Rust instead of Node because I want to write TypeScript, but I don't want to build a build system. And TS Node or any of these other runners are just really annoying to set up. And then setting up everything is also super annoying to set up. So I just tend to not ever use that. But now that Bun's there, maybe I could see myself using it, but there's still a lot more that I'll have to think about. You know what I mean? A TS Node hurts. It does. It's an emotional pain. And then you got like this TS paths issue. And it just, every single time I get super pissed off at it. You know what I mean? I get just super pissed. Yeah, Dino. Maybe I do need to invest a little bit more into Dino. Yeah, I agree. By the way, I'm fully in agreement with Stryker. I have a video dropping here maybe next week on Bun and my real impressions of Bun. It is not production ready. 1.0's a lie. The name is the Asyncogen.